Hi ladies and gentlemen, this is Mr. Green, and this is another in my series of lessons on pre-cal, and I appreciate you being here and listening to my lessons here. Uh, where you should be, it appears that we are starting up Unit 4, so that means you should be finished with Unit 3, or at least trying to finish up that unit test for Unit 3 and getting that turned in. The first part of Unit 4 is some stuff that you probably have heard several times in the past. I know that you had it in Algebra 1 and you probably had it before that. It's just talking about exponents. So when you see something that says x to x and this 2, 3 is raised up like that, that means it's raised to the 23rd power. That means it's x times x 23 times. Okay? So when you are multiplying things that have exponents in them, like this one here, x to the 12th times x to the 7th, you would take the 12 and you would take the 7 and you would add them together. Not a big deal there. It's just a matter of adding two numbers together, 12 and 7, giving you 19. So if you are dividing them, you always do the ones on top first and add them together first, and then you'll do the ones on bottom. So if you have x to the 12th divided by x to the 7th, you would say 12 minus 7, giving you x to the 5th. Now I'm saying this, and I'm not really specifying it, but I should be. Anytime we're doing this, the base has to be the same. So it's an x and an x and an x in every one of these both of these two cases, when you're multiplying and when you're dividing. You're doing it against the same base. You're not changing the base at all. Okay? Make certain that you're doing that. There's a couple of examples where people have multiplied the bases together too, and that's not what we do. We just add the exponents on the same base and leave it alone. Okay? So, if we're translating a graph of something that is x to the third, for example, if we were trying to translate that graph, now translation means moving it, and we're going to use this f to the third graph here. Well, we know what x to the third should look like. If you drew the x and the y coordinate, it would look something like that. Okay, x to the third. If we translated it, we add something here at the end, plus 3. That's actually going to move this 3 units down to right here. And it's going to go like this. Like that. Just like that. Okay? If you subtracted 3 from it, it's actually going to move it up 3 units. So it's going to go like this. Okay? So that's the way that you translate them up and down. Now, if you were going to want to translate it to the right and left, you would actually be affecting the x values there. And so by doing that, you have to actually have x value, you have to affect the x itself. And so what you would say is x minus 3, and that would take like a quadratic like this one. That would be the x squared function. X minus 3 would move it to the right 3 units. So it would be over here, and it would do this. Okay? X plus 3 would move it back to the left 3 units, and it would do this. Okay? So it's a right and left movement. And yes, these do seem backwards. You're adding 3 and yet it's moving to the left. And you're subtracting 3 and you're moving it to the right. It's the same thing when you're doing the up and down movement. See how it says you're adding 3, but we did go up? But this is actually affecting the y value that's over here. And it would be f of x minus 3, and so it would go up. And that's the way I always remember it, is it's using the opposite sign. And that's the only way that I can remember how that works. Okay? Okay, now if you were shrinking it or trying to stretch it, well, there has to be a variable in front of it, like that a right there. Okay? That a would represent how much shrink or how much stretch you're getting to the formula for x of n. Okay? So when you stretch it, it's going to get bigger. That means the bigger the a, the narrower it's going to get. It's going to shrink it in a little bit, but it's going to get narrower. Now, how does that affect an f to the third? Well, that's not one. That's an f to the third. What that means is that these values here would get closer to the y-axis. So that would be an f to the third with a bigger a, something more than 1. Okay, it would shrink it in like that. And if I go with a number that's very small, like 1/2 or 1/4 or something like that, it actually would cause it to get wider, like that. That's what happens with those a's. Now you got to remember that a value affects more than just the shrinking and narrowing of a graph. It also affects the behavior on the right hand side. A positive a value points up on the right for all values of x and n, but a negative value will point down on the right. Now, if your n, whatever you're raising, whatever exponent you're bringing it to, is an even number, both the right and the left point the same direction. If it's a positive, if it's a negative, I'm sorry, if it's an odd number, they point in opposite directions. And that's all you have to remember about that in behavior. Well, like I said, exponents is something you've probably had in the past and haven't had to deal with. One of the things you might not have been able to realize or might not have known is if you bring something to a fractional power, a fractional exponent, that's like taking, oh, let's say the root of a value. What do you mean by the root? Well, we've all done square root, okay? And so you found the square root of x to the of 4, and the square root of 4 is 2 or negative 2. And have you ever found the cube root? The cube root of 8 is plus or minus 2, right? Well, no, it's just a negative 2. But you've found those roots in the past, okay? But I don't know if you've ever done one that is a fourth root or a sixth root or a fifth root or a seventh root. In the lesson, they actually ask you to come out here to this. Oops, I got a plot on. I'm going to turn that plot off so that we don't see that. Thank you. Now, it's asking us to go out there and plot x, and I'm going to push this little button right here, which says raised to the power. I'm going to put a parenthesis in here, put 1 divided by 4. When I take something to the fourth root, I'm taking the fourth root of something, and you graph it, zoom, normal, standard, thank you. When I take it to the fourth power, I get something like that. Okay? Well, what happens if we take it to the sixth power? Well, I can run over here and take this out to a 6, and graph it again. And what you'll see is it looks very similar. But you can't really see a difference here unless you plot them both at the same time. So I'm going to come down here and plot another one just like it. X raised to the fourth power, 1 divided by 4, close parentheses, and hit graph. And I think you'll see that's the sixth power right there, and the fourth power looks like it's right on top of it. It is. It's a little bit higher up, but right on top of it. And so what you're going to see is something very, very similar. Well, what about the fifth and the seventh power? Well, we know that the fifth power might not look the same because it's an odd, that's an odd number in the denominator. So I'm going to change that one to 5, and I'm going to come over here and change this one to 7. Okay, and I'm going to graph them. Okay, oh, there's one to the fifth, and then there's the one to the seventh that's a little bit inside of it. Okay, yeah. So they look very similar like this. That's very interesting how those work. So if it's an odd number, it does both this positive quadrant 1 and then this quadrant 3 values. If it's an even number, it'll only be in quadrant 1. Okay? So those are the things you need to keep in mind when you're doing things like that. But that does represent the fourth root, the sixth root, the fifth root, the seventh root, things like that. So that's where that is coming from. Okay? Now, one more thing about these type of things. How do you move them up? You add to the end outside of the radical. What do you mean by outside of the radical? Well, what you would do is you would say f of x is equal to x raised to the 1/2 power, that's the square root, plus 2. That plus 2 would actually take it down, or take it up 2 units. Okay? And if I do that, let's go back to my calculator here. And I do that to one of these so that you can see the difference in them. I'm going to come over here and I'm going to come outside of the radical. There it goes. Plus 2. And I graph this, and it should take that one so that it's up here, yeah, at 2. See how it moved it up 2 units? That's what that's doing. If I want to move it right and left, I have to affect the x. That would be inside of the parentheses and needing to be affected by the power. What am I saying there? That means f of x would equal, and I put a parenthesis, x minus 5 raised to the 1/2 power. Okay? Well, let's look at what that would do on a calculator, just to show you what it would do. I'm going to take this second one down here, and I'm going to put parenthesis x minus 5. That should move it to the right 5 units. And I hit enter, and I hit graph, and so we'll see the first one that was moved up 2 units, and the second one should be moved over 5 units out over here. And there it goes. It's moved up 5 units over to the right. Okay? And you can see the difference there is this one, I'm affecting the y value, because if I subtracted it over here, it'd be on this side over here. This one, I'm actually affecting the x value, and it does affect moving it to the right. Okay? If I wanted to stretch it, a constant in front of the bigger number, a bigger constant in front, the bigger number would cause it to get smaller. A smaller number would cause it to get bigger. Okay? Negative number rotates it around the x-axis. That's an interesting one. Maybe you ought to see that one just to know what it is. So if I take this y equals, if I insert a negative sign like that and hit graph, it now rotated it around the x-axis. See how it's up over here and came down? This one will go back and go back up like it was normally. That's what we just did. It rotated around, it rotated around this y-axis right here. Is that what I'm saying? That's supposed to be y-axis. Okay? A negative x is what I'm looking for there. That'll rotate it around the x-axis. I wrote those down backwards. Sorry. Okay? What am I talking about there? If I do this one here, and I come down here and make instead of being a positive x, I insert in a negative sign there. Got to be in the right place. Doesn't make any sense if you're not. Right there. Second, insert negative sign, and hit enter. And then graph this. It should take it and rotate it around this x-axis right here. It did. It rotated it around the x-axis. It rotated around the y-axis because it was intercepting over here. It's now intercepting way over here. So it rotated this way. Okay? That one went around the y-axis. So why did I think this one went around the y-axis? Okay, well, I'm going to have to experiment with that one a little bit because I'm looking a little bit confused right at the moment. Dazed and confused Mr. Green. Okay? What I need you to do is you experiment with it and you tell me which x causes it to rotate around the x-axis, which change in x causes it to rotate around the x-axis, and which one changes around the y-axis. Because you need to be aware of those things and know which one causes which change. Okay? Because it does make a difference. You will see a difference in them when you look at the squared numbers and the even numbers that you'll be looking at. Okay. Having done this, You guys are really good about making certain you're telling me that you're in the pre-cal class. It really does help me find your information a little bit quicker and respond to your questions. It does help. If you're having questions and you want to have your questions answered, please feel free to come to Toga between 3 and 4 o'clock on Monday through Thursday, or 11 o'clock, 12 o'clock on Friday. I do want to answer your questions. Had a little bit of technical difficulties this week, but we'll be back there again next week, and you're welcome to come ask questions, get your questions answered. Okay? So, I'll look for you next time.